Okay, so this video is to help solve question 14 on page 206 in the Nelson Advanced Functions textbook. So the question gives you that during a normal 5-second respiratory cycle in which a person inhales and then exhales, the volume of air in a person's lungs can be modeled by this equation, that volume of time equals 0.027 t cubed minus 0.27 t squared plus 0.675 t, where the volume V is given in liters at t seconds. The first question asks, what restriction or restrictions must be placed on t? The second question asks, if asked, how many seconds have passed if the volume of air in a person's lungs is 0.25 liters? Would you answer this question algebraically or by using graphic technology? Justify your decision. The third question asks, solve the problem in part B. As you can see, the equation has a cubic polynomial, so we are dealing with the polynomial functions of this course. The key elements of the problem are the duration of the respiratory cycle, which is 5 seconds, and the equation that models the volume of air in a person's lungs, which is V of t equals 0.027 t cubed minus 0.27 t squared plus 0.675 t. So question A asks, what restrictions must be placed on t, which is time? Because time cannot be negative and the question gives you that a normal respiratory cycle is 5 seconds in length, we know that the restriction on t must be between 0 seconds and 5 seconds, including 0 seconds and 5 seconds. So question B asks, if asked, how many seconds have passed if the volume of air in a person's lungs is 0.25 liters, would you answer this question algebraically or using graphing technology? Justify your decision. Since this question involves decimals in all the terms, solving it using graphing technology would be a better strategy since it is much simpler to use and factoring decimals is quite difficult. Question C asks, solve the problem in part B. So we know the equation is 0.027 t cubed minus 0.27 t squared plus 0.675 t. And question B asks, how many seconds have passed if the volume of air in a person's lungs is 0.25 liters? So we have to make this equation equal to 0.25. And afterwards, we have to bring the 0.25 over to the right side, making this equation equal to 0. So 0 equals to 0.027 t cubed minus 0.27 t squared plus 0.675 t minus 0.25. Okay, to solve this question graphically, if you have a Mac, you want to go into all your applications and then go into Other and find the application Grapher. When you open it up, you go to Default and click Choose. And then in the equation up above, you want to type in the equation 0.027 x exponent 3 minus 0.27 x exponent 2 plus 0.675 x minus 0.25. You switch t for x because this graphic calculator only uses y and x, so you have to change your volume to y and your time to x. Then afterwards click enter and you get your equation, and it looks something like this, a cubic function. So when you zoom in, you want to look at your zeros, which will give you the time at which a person's lungs have 0.25 liters of air. So if you look at the zeros, we have 1 0 right here, which is at 0.43 seconds. So that would be the first time that a person has 0.25 liters of air in their lungs. And here's the second 0, and if we zoom in right here, it is at 3.33 seconds. So if you don't have a Mac, you can go on Google and search up a graphing calculator. And you want to click on the fooplot link. And then you want to change this function to 0.027 x exponent 3. The exponent button is shift number 6 minus 0.27 x exponent 2 plus 0.675x minus 0.25. You want to click enter, and your function will appear as a cubic function, just as the same on a Mac. And if you zoom in, you want to look at the zeros. So the first 0 is right over here. So if we zoom into this, you can see that it is near 0.45, which is close to 0.43 as we stated on the Mac software. As when you use graphing technology, it won't be exact, but it'll be pretty close. And then the second 0 is over here, and as you can see, it's between 3.2 and 3.4, but closer to 3.4, so we can assume that's 3.33.